Welcome back, friends and neighbors, to another networking video. Today we're entering the world of the IETF RFC, and today's favored RFC is RFC number 1 from 1969. But first, a milestone. So this is a quote from the article referenced at the bottom of the slide. Many realize that, well, now a little bit more than 50 years ago, on October 29th, 1969, the first message was successfully sent over the ARPANET. Of course, this is the precursor to the internet, but few know the story that led up to that message. So on June 3rd, 1968, the ARPANET program plan was formally submitted to the U.S. Department of Defense Advanced Research Projects Agency. It was approved on June 21st, 1968, and that meant that the ARPANET process was now officially underway. By the way, another milestone might be that the U.S. space program was hitting its stride at this time. So RFC 1 sort of outlines some of the discussion and the issues associated with getting ARPANET on its feet. So if you take a look at the very first RFC, we can see that it dates from 1969. The author is Steve Crocker, and we're really talking about host software. It's a really short one. You can take a look at it. It's only 10 pages long. And here's a little clip from the opening. The software for the ARPA network exists partly in the IMPs. Well, we'll get to that. And partly on the respective hosts. BB&N has specified the software of the IMPs, and it is the responsibility of the host groups to agree on the host software. So if you think about that for a sec, long before computers were actually connected on a regular basis like we do today, we had to sort of figure out not only how you were going to do it, but also how you were going to get hosts to agree on what they were going to use, and then interconnectivity via something called an IMP. During the summer of 1968, the representatives from the initial 4 sites, Utah, SRI, UCLA, BB&N, there were a couple other folks, met several times to discuss the host software and the initial experiments on the network. So on the right, we can sort of see an image of what they were thinking about, right? 2 terminals, one in UCLA and one at SRI, or the Stanford Research Institute, and then we've got the communication software necessary, and then the link that's going to be used to connect it. And these rules are very, very similar to what we have to deal with today, right? So information is transmitted from host to host in bundles called messages. A message is any stream of not more than 80 bits. Now, if we put that in bytes, right, we divide that by 8, and we get a unit, a size, that is very similar to the chunk of data that we send over modern communication networks today, which is 1500 bytes. So very, very similar size, going all the way back to 1969, together with its header, and the header is 16 bits and contains the following information. A destination makes sense, right? Who are you sending this to? And then some details about the link over which it's going to be sent, some spare bits. And we still have spare bits in protocols today. That is, bits that are either must be 0, MBZs, or that are not used or for future extension. The simplest connection we can imagine is where a local host acts as a TTY or a terminal of some kind and has dialed up the remote host. Each host operating system must provide to its user level programs a primitive to establish a connection with a host. So think socket right there. And a primitive to break the connection. So somehow you've got to open it, somehow you've got to close it, and somehow you've got to communicate to the software programs that you have this network link. Today, we use the TCP/IP model all the time, and if it's UDP, we're just going to open up a socket. But if it's TCP, of course, we have the handshake. So some fun details about Dr. Steve Crocker, the author of this particular one. Not only is he the author of the very first RFC, he actually invented this whole sort of idea of, hey, we can put out a request for comment, get people to beat it up a little bit, and come up with a better standard. But he was also the founding director of Aerospace Corp's Computer Science Lab, a co-founder of CyberCache, an early way of doing business over the Internet Hall of Fame 2012, and so on and so forth. And if you want to learn a little bit more about Dr. Steve Crocker, or maybe the early days of the Internet, there is a link to his People site. at UCLA. And as always, I like to point out a couple of fun excerpts or fun ideas about the RFC itself. Open questions about the IMP software. These are right in the RFC. If the IMPs do code conversion, the checksum will not be correct. We run into that all the time with network address translation. Even today, you got to recompute the checksum, which is why NAT boxes can be slow sometimes. The procedure for requesting the Dell front end is not yet specified. Dell was the programming language that they used. And for heaven's sakes, what's the rule on acronyms? This RFC is filled with acronyms that are never explained. What's an IMP? Oh, well, it turns out that was a network interface message processor, so my IMP image is probably not the right one. Who is BB&N? Oh, well, BB&N is actually Bolt, Beranek, and Newman, now Raytheon, so they were involved in the original creation of the code and the machines that were actually the IMPs. And a fun little quote from the RFC, BB&N claims the host IMP hardware will be as reliable as the internal registers of the host, that is, inside the computer on the host machines. We believe them, but we still want the error checking. Another acronym, SRA. Oh, that's the Stanford Research Institute, and they're still around today. Well, this has been a close look at the very first RFC. RFC number 1, host software and IMPs. Now, some of the details of this I got from Leonard Kleinrock's post over at ICANN. But here's a little bit more about Leonard Kleinrock. He was actually involved in the early days as well. A very fun video to take a look at is the mother of all demos out at YouTube. It is an early version of what a GUI interface might look like. It's worth scrolling through real quick, even if you don't actually watch the whole video from start to finish. But there you go, some good stuff to take a look at. Hey, thanks for watching, thanks for listening. Like and subscribe if I helped, and may those packets always reach their destination, even if you're using IMPs.